Hi there. This is a little video that's introducing people to an R package, which is in development, which is called ArgoFloats. And it works with what are called ArgoFloat data. It's an oceanographic kind of data. Really, I think the video won't mean too much to anyone unless they're familiar with oceanographic data sets, and in particular the ArgoFloat program, which is an amazing program, by the way. So there's going to be two people on this video, and we're doing this in the beautiful Halifax, Nova Scotia on an incredibly gorgeous day, and there's no contrails in the sky. And that tells you that we're in the middle of the stay-at-home advisory because of the COVID-19 problem. And the people on the call are me, and I'm a prof at Tallahassee University,
and I'm Jamie Harbin. So right now I'm working at the Bedford Institute of Oceanography and soon to be moving over to Dalhousie University.
Right. And Clark Richards, also at the Bedford Institute of Oceanography, is not with us today, but he's a co-developer in this project. Now, what we're going to do, we're going to show you screens here. One will be from a web browser, and the other will be from something called RStudio. And RStudio is sort of a GUI system, a graphical system for working with the R language. Some people call it the R statistical language. I prefer to just call it the R language. But a great strength of R is that it has tons and tons of statistical tools. So for scientists, this is wonderful because you can focus on maybe trying to get your data and manipulate your data. And you don't have to think about how to do fancy statistical analysis because R has that built in. This makes it a real strength, and that and the stuff that's built into R through this something called CRAN. It's a comprehensive archive network. It's very well vetted, very well tested, and it generally, I think, is pretty high quality code. Typically, if someone is doing a PhD on some fancy technique and stats, nowadays they would be doing their coding in R. Very, very common for them then to donate it to the CRAN project. So high quality code, well vetted. And the main thing is it saves the scientists from having to spend a lot of time worrying about how to do fancy statistics, and they can focus instead on the data. So speaking of data, the Argo program is a program that's been going on for a couple of decades now. By the way, this video is being recorded just before Easter in the year 2020. So this program, it involves things called floats, which is a weird word because they actually go up and down. And we're supposed to call them floats and not profilers, but I call them profilers because they go up and down. In other words, they make a profile in the ocean. Anyway, there's tens of thousands of these in the ocean, and they stay at a parking depth of about 1 kilometer. And they drift at that depth for about 10 days, and then they rise to they go down to 2 kilometers if it's deep enough. And then they rise up to the surface. And as they're rising, they make a record the temperature, salinity, and some instruments record also oxygen and other things. Now the data set for these is huge, and there are a couple of repositories. And what we've done in ArgoFloats is we've made it easy for an oceanographic analyst to acquire data from these archives. And that's kind of no mean feat, actually. It's a bit of a hassle, even to remember where the archives are, to be honest. And navigating through them is a little bit tricky as well. We're not saying that there's no other way of working with such data, but this is one way that we've made, and we hope it will be useful. So before I go on, have I sort of forgotten anything, Jamie, would you say?
No, I think you definitely, kind of touched on everything that we thought was important to mention at this point.
Okay, good. So the view that people can see at it's a web browser. At the top, you can see the website where we have this. Maybe, Jamie, you could scroll to the top of that website. Now, this is a GitHub website. Most of you are probably familiar with GitHub. And I'd have to say that a negative of the GitHub website is that it's fairly daunting. There's a whole lot of stuff there that's really for developers. All those lines at the top are for developers. Where you really want to be looking is in this place there where you see the word ArgoFloats. And this is the README file. And first off, there are 3 icons there. And the first one is, okay, the first 2 are what's called continuous integration or testing or something. The one on the left is called Travis CI, and the one on the middle is called @Veyor. And what happens is that whenever we make a change in argoFloats, these are other websites that pick it up. They run the package. They run through the test suite in the package. So if you see 2 green lights there, it means that the most recent changes have worked out okay. The third one you see is called code coverage. And it's saying that 29% of the code is sort of lit up or run when we only have 10 minutes left here. I have to click this to make that go away. Ignore what I just said if you don't see the little pop-up menu that I saw. Yeah, so 29% of the code is lit up or tested in the test suite. The reason why it's not a much higher number is that we don't want to have tests for when this goes on to CRAN. We don't want to have tests that download data, and a lot of this is about downloading data. Now, the gray, the part that has a gray underlay shows you how to install this, and it's not on CRAN yet. argoFloats is not on CRAN yet, so you install it by those 2 lines. Now, if you don't have devtools installed, you have to do install.packages, parenthesis, quote, devtools first. And most people will have devtools installed. And since these steps can take a little while, we're not going to burn up time by showing you how that works. Down below is a little bit of sample code, and that's a good place there. And so, and again with gray, that's sample code written in R. And below, and what this code does is it gets an index, that's the 3rd line. It knows where to get an index. There's an option to this function called getIndex to go to one repository and another, and it basically this knows 2 of them, and it tries first, I don't remember, the American one and then the French one. I don't remember the order that we have. The only argument we're giving it is one called destdir, and that's destination directory. What we're saying there is we want the index and all the data to go into a directory in the top level, subdirectory called data in the top level, and a subdirectory of that called Argo. You can use anything you want for that. If you don't give that, it goes, anyway, you can give anything you want for that. It depends on how you organize your data. When you do that line, what it does is it downloads the data if the index is more than a week old. So in other words, it caches the last index for a week. And you can change that with a parameter. If you want, you can put the age of 0, and then it will get the index every time you do it. Jamie, can you click the other tab, and we can show the viewers the repository. So that's the repository, and you can see the address there. That's the US Goodeye one, but the French one looks similar as well. And all those files there, like the 2nd and 3rd, notice that the 2nd ends in .txt, it's a text file, and the 3rd ends in .gz, GZ for the Americans. The GZ ones or the GZ ones are gzipped, so they're just a smaller version of the other. And if you look at the one called prof there, prof text, profile.txt, it's 38 megabytes. And uncompressed, it's 200 megabytes. This is pretty big, and this is just an index. All it does is it tells a file name, float number or identifier, a longitude and a latitude, and a time, and maybe some other information. Even just that then locally is a 200 megabyte file, and the download is 38. That's why we cache it. We don't want to bother with that. Now there are several varieties here. There's the normal Argo, and down below is one for what is called their BioArgo, which more recently is being called BGC for biogeochemical, I guess that's it, Argo. And then there's merge, which merges together the ones that are just physical and the ones that are biogeochemical. And that's where the indices are. And then there's a thing called DAC. Maybe you could click on the DAC, Jamie. And maybe we won't do any further clicking, but these are just different sort of, I don't know, data acquisition center, I guess is what that's called. And buried somewhere deep in, maybe you just click on one of them, AOML, that one. It says for Atlantic Ocean something, I don't even know. And this might take a little while. This is kind of the point of using our package, is that some of these things take a long time. We may actually give up on this if it takes much longer than this. Jamie, let's go over to the let's go back to the README file. So I guess we've inadvertently proved our point here, which is those downloads take a long time. Even get a file listing takes a long time. So you don't want to do it manually. So what I'm going to propose, Jamie, is that you cut that code, not the install part, but the other code. Yep. We're going to reproduce that figure. And so we're going to copy that and we're going to paste that into an RStudio window. So this is an RStudio window, and yep, just paste that. And yeah, so what it's doing at the moment is it's getting the index. This index is actually downloaded, but it still had to read the thing, and it still takes a couple of seconds to read that 38 megs compressed. And then it did a subset. Jamie, can you make it so that the console is bigger and they can see, so it's not cut off just for a sec?
So,
oh no, maybe ignore what I said because the plot's coming up, so we don't want to mess up the plot. Okay, so then the next line, so the first line says we want ArgoFloats. The second line says we want OCE. That's because ArgoFloats uses OCE for some plotting. OCE is on CRAN, so you can get it from there. Let's not resize because it messes up the plots. And then we get index all, that's the whole index. And then we do a subset. We're doing a subset, which is a circle around the stated longitude and latitude. It's a place in the Bahamas. And at a radius of 30 kilometers, 30 is in units of kilometers. And it replies that it found 39 profiles, which is whatever that is, 0.02% of the whole data set. And then the next thing that we did was we did get profiles. That downloads the data. We've already downloaded these data. If they hadn't been downloaded, it would take maybe 39 profiles, maybe a second for each. I'm not sure. The net CDF files are maybe 50 or 150 kilobytes, something like that. Okay, and then we read them. So at the line where it says read profiles, at the end of that, we have an object. This whole thing is object oriented, by the way. We have an object which is understood by this package. Then we say we want to have a plot with stacking together two columns. And then we say I want, we plot the index, which has lat and lon, and the type that we want, we indicate by which, and that says map. That gives the left-hand panel. The whatever is that color, brown is land, and then the dots are for the ArgoFloats. And then we plot the temperature salinity diagram on the right. And the temperature salinity diagram here is showing you in what's called the TIOS-10, or the Gibbs seawater way of working. That's showing what's called absolute salinity and something called conservative temperature. Actually, there's an argument. If you want to use the old-fashioned so-called UNESCO approach of practical salinity and potential temperature, you can do that too. Well, anyway, the point of this, I think, and in the top right there, you can see the global environment. And so you can see that the index is a class, and the profiles is a class, and well, anyway, etc. These are ArgoFloats classes. That's what you can see that. I won't bother going into that. Now, Jamie, if we could go back to the browser and scroll to the very bottom. So you can see, anyone who's following along, you should be able to reproduce this sort of a diagram. And what we'll talk about in future videos, maybe we'll do about one a week, just say that so it's not like we're going to have 3 days where we do 50 of them, and also we're not going to wait for 4 months. So I think that's it for now. So this is Dan signing off.
And Jamie signing off.
Okay, so stay tuned for more videos. Thanks for your attention. Please go to the website, and if you want to have changes made to the package, you can let us know by registering an issue. Certainly if you find an error, let us know. Package is still in pretty active development, but I think it's really ready for some work, and we'll be writing a paper about the package over the next short period of time. So stay isolated, Stay safe and let people know that you love them. Bye-bye.
You.